Hello everybody, welcome to this short course on dynamics and control. We are going to spend the following days developing this interactive course about the basic concepts on systems, control and their impact in all the human activities. My name is Pedro Albertos and I am Professor of Systems Engineering and Control at the Polytechnical University of Valencia in Spain. In our course, we will develop several modules, and each one of them will comprehend different videos and also some questions and exercises, as you will see. The first one will be examples of systems and signals, just to know what we are going to deal with during the course. These systems and signals will be modeled, and the second module will be developed this kind of models. In particular, we are interested in systems which are controlled. Then we will analyze the properties of controlled systems, and we will try to learn a bit about how we can design control systems. Well, all this is because we get a lot of benefits from the control, and we will devote a module on control benefits. And finally, we will develop some tools to analyze and to study the different topics that we have been treating in the previous modules. So let's start with some examples about systems. Then a system could be, for instance, a mobile. All you know what is a mobile, or a car, of course, all you also know. This is a system, but we have systems also in the industry where we are a robot, like here, and also where you have a workshop where you are mounting, assembling some cars, for instance. But you have also systems in the nature. For instance, here you can see a fleck of birds, and they are interacting, they are exchanging information, so they are coordinating in some sense. So they constitute also a system. But systems can be also very small scale, like for instance in the molecules, which are also composed by many small components interacting among them. If now we move to signals, for instance, here we have a metronome, and we can see the signal coming from this, but you can also realize a record of signals at different frequency coming from a thermal process, for instance. This, you see that the signals could be very simple, like in the first case, or they could be very complicated. They could have a simple shape, like in this graph, or they can be combined with different graphics on the same plot. But the most important is that signals carry some information about the systems they provide from, or just information we are interested in. For instance, information could be the temperature in the room, could be the speed of the wind, and this is information for us to react and to perform some activities. So the first module will be in detail some examples of systems and signals. In particular, we will be interested in dynamic systems and the concept of feedback. Feedback is a key concept in our course. Feedback is the most important concept appearing in many fields in the science and engineering. Then, once we know about the systems and signals, then we will try to model. For instance, here you can see three different systems. The flow of the water in the river, the flow of the cars in the road, and also the information flowing on the cable. They are very different in supporting the technology. In one case is hydraulic, in another case is just cars, or is just electronic information. But all them have some similarities. And that means that even they appear to be so different, they can be modeled in a similar way. And the same happens with signals. We may see here different signals, and they bring to us some information, but they can be characterized, this information can be characterized and it can be represented in models which are very easy or more easy to store, to transfer, to discuss and to understand the process itself. So we will see representations of systems and signals, and we will see also about analogies. Well, as I mentioned at the beginning, we are interested in controlled systems, so we will see some properties of the controlled systems. For instance, most of the systems are of the kind of reaction. We are feeling cold, and then we start to tremble to raise up the temperature. Or on the other hand, if we feel too hot, then we put some air to be more refreshed. And one of the very important properties of the systems when they are controlled is the stability. If you see at this boy on a bicycle, then of course this is a system, and he is acting in such a way that he is keeping in the vertical position over the string. So stability is not so funny like here, but very important in all the systems. So we will have a module about the static and dynamic behavior of the systems, and about the sensitivity and robustness of the systems, the dynamic systems. Then we will see about how we can design control. For instance, here we have a power plant or steam generator. Then we have in the center we have the drum where the water is boiled and the water is circulating, and we are getting some input of water, some input of fuel to burn, and we are getting out some steam. And then we want to keep this plant, which is much more complex than the examples we have seen before. We want to keep this plant operating and some given conditions. For instance, we want to keep the level of this drum, the level of the water. We want to keep the temperature or the pressure of the steam. And for that we need a control system. The control system is taking some information from the process. We are getting some information about the level of the water and also the temperature of the steam. And then with this information and some requirements, we are recording the evolution of the system, or we are just acting, opening this valve or closing this valve. So we are controlling. And then we need to design this control system. So in this module about control system design, we will see the components that we have been discussing before, the sensors, the actuators, the controller itself, and we will try to give some idea about the performance of the control, something which we can say in a qualitative way: it's good, it's very good, it's bad, it's not very good. But we will put some measurements, some figures to indicate what is the performance and what is the quality of the control. As I said at the beginning, the main aim of the control is to keep the system running in some given conditions, and then by this way we obtain some benefits. So the main benefits of the control is improve the security, improve the comfort, improve the performance, and also to foresee for new applications. New applications which are not easy or not feasible if the control is not good enough. So in this module, we will analyze the perspectives of the control and which are the control challenges. Finally, in the last module, we will discuss what are the main topics to study. We must to observe, to represent the systems, the signals, and we must to design in which way we make a control system to achieve some performances. Then, in this module, we will see tools for analysis and modeling, some tools for design, and we will discuss briefly about the problems in implementing control systems. So, what have been seen today in this session? Mainly, what is the contents of a short course on systems, signals, and control. And we have been discussing what are the main concepts and what are the main problems and how to deal with them. So what is next? Of course, we are going to start with the first module. Then we will see examples of systems and signals, dynamic systems and feedback, and we will see the variety of systems and the variety of signals that we can find in reality, in nature, and also in human-made systems. Well, that's all for today.